Hello everyone, welcome back. I'm Akash Joshi, I'm the OR guru, and today we're going to be talking about linearizing products which contain non-binary terms. I've created videos on how to linearize products that have binary terms, but I've never talked about non-binary terms, which can be a little bit more complicated. Okay, let me explain first how to do it with normal binary terms. If you want more information on this, please check out my other video on this. Alright, so say we have the objective function x1 times y2 plus z minus 3x2. And right now this is a nonlinear program because we're multiplying x1 and y2. And anytime you multiply two variables, it becomes nonlinear. So x1 and y1, let's assume that they aren't binary. And if they were binary, here is how we would solve it. So let me explain how we would solve this. First, we would pretend that x1 times y2 is the same thing as w. It's just another variable to replace x1 and y2. W plus z minus 3x2 would become our new objective function. And because we can't say w equals x1 times y2 because that would just be another non-linear program, we have to use these inequalities to define w and make it practically the same thing as x1 times y2. So let's take a look at these inequalities. W is less than or equal to x1, and W is less than, or there should be an equal to sign there. W is less than or equal to y2. Now, x1 and y2 are binary variables, okay? Because we're assuming that they are binary. And since they are binary, our W value becomes exactly how it would be if the W value didn't exist. What do I mean by that? Let's take a look at this chart over here. Okay, so if x1 and y2, that should say y2, if x1 and y2 were in the objective, not in the objective, but in the, if x1 and y2 were in the objective function and their values were 0, then if you multiply them together, that's still 0. And for w, that would still be 0 because over here, it says that w is less than or equal to 0 and w is less than or equal to 0. So then w has to be 0. Over here, if x1 is 0 and y2 is 1, then we're saying w is less than or equal to 0 and w is less than or equal to 1. And since w less than or equal to 0 is more binding, w has to be 0. Because if w is less than or equal to 1 and w is less than or equal to 0, then w has to be less than or equal to 0. And yeah, so that means w is 0. Now, it's the same process for if x1 was 1 and y2 was 0. If they're both 1, then w would be less than or equal to 1, and w would also be less than or equal to 1 for the case of y2. And since they're both less than or equal to 1, and we are trying to maximize the value of w, then it should be 1, right? W would just be 1. It's not going to be smaller than 1 because we're trying to maximize W. That means make it as big as possible. So yeah, that's pretty much how you would linearize x1 times y2 if this were binary. And remember, we're just assuming that this is binary. I'm clarifying that they are not binary, and we're going to take a look at that. That's the whole point of this video. We're going to take a look at how to linearize that if they're not binary. And yeah, this is pretty easy linearization. What I'm going to show you next is kind of more complicated. Well, the example isn't really that complicated, but it can become really complicated, and it's important you understand the foundations right now. Let's quickly take a look at the problem here. The problem on the last page was simply an example problem that I was going to use to show you how to solve binary problems. Okay, so there's a business that produces and sells 2 types of alcohol, and there's a fixed payment that is required to pay for the license, to acquire the license, and that's required by law. Not getting the license would be illegal. How would you formulate this problem? I haven't given you any numbers. You can make up the numbers for yourself, like the profit you get from selling the alcohol, the resource constraints. But here, let me just show you the formulation so that you don't have to do that. Okay, so let's look at the formulation. 15x1 plus 6x2, that means we can get $15 a profit for the first alcohol and $6 a profit for the second alcohol, assuming that we pay the fixed payment. And z is binary. it's either 0 or 1. But notice how x1 and x2 are not binary because x1 and x2 simply represent the amount of the bottles of alcohol that we produce or sell. Okay, so we're trying to maximize our profit as usual, and we are subtracting the $15 worth of a fixed payment. And these are resource constraints. So 3 of one resource are required for one product of alcohol 1, and 2 units of this resource is required to produce alcohol 2. And you can follow that same methodology for this resource constraint. And of course, the amount of number of bottles that you sell or produce has to be greater than or equal to 0. You can't sell negative numbers of alcohol. And Z is binary. You either pay the payment or you don't pay the payment. If you don't pay the payment, Z is equal to 0, and if you do pay the payment, then Z is equal to 1. Now let me tell you how to linearize the formulation. I have put the formulation here in case you need to refer to it, and that way you won't have to skip to the earlier parts of the video. Okay, so let me just explain to you how we would linearize this formulation if the variables were all binary. And of course, they're not binary because x1 and x2 are not binary, but if they were binary, I'll show you how to do it, and I'll show you why that's wrong. Okay, so first replace x1 times z and x2 times z with w1 and w2 respectively. And we can't just set w1 equal to x1 times z because then the program would still be nonlinear. And of course, we're trying to linearize it. So instead, we have to use inequality signs to practically ensure that w1 is equal to x1 times z and w2 is equal to x2 times z. Okay, so the way we would do this if the variables were binary is that we would upper bound the w's because we're maximizing w. So if there was no upper bound to w, then w would keep maximizing until infinity. So we have to set a upper bound for w. And we do that with less than or equal to symbols. Okay, so the reason why this part is wrong is because w1 less than or equal to z and w2 less than or equal to z is too restricting. And over here we have that z can only be 0 or 1. So if we're selling like 8 products or 8 bottles of alcohol 1, then it would be w1 is less than or equal to 8 and w1 is less than or equal to 1 because z is binary. So since z is binary, w1 is less than or equal to 1 no matter how many bottles of alcohol 1 we sell. And since w1 would be less than or equal to 1, w1 would have to be 1, and that's too little because we're selling like a lot of bottles of alcohol 1, and 1, the number 1 inaccurately represents that because it just implies that we've only sold 1 bottle of alcohol type 1. And the same goes for w2, and that's why this linearization strategy cannot be applied to non-binary variables in this formulation. All right, here is the correct linearization for this problem. What we are going to do instead of setting w1 less than or equal to just z is we're going to make it 4z. Why 4? Because if you look at the constraints for the resource constraints, the maximum number of types of alcohol 1 that you can produce is 4 because 3 times 4 is 12, and 12 is how many of the resources you have in the first place, and you won't produce any of alcohol 2. So if you produce 5 bottles of alcohol 1, then you would have a 15 here, and then using simple math and using simple algebra, that would mean 2x2, x2 would be negative. Okay, and of course x2 can't be negative since we can't sell negative bottles of alcohol. So that means w1 is less than or equal to 4 times z. That is the upper bound. So that way W1 is less than 4 because we can only sell 4 bottles of alcohol anyway, so it doesn't matter if W is 4, 3, 2, 1, as long as we know that W is less than 4. Less than or equal to 4, let me clarify that. Okay, and then for W2, we're going to set it equal to 10 for the same reasons, for resource constraints. And sorry, this is incorrect. This should be 5. Yeah, it should be 5 because the max amount of 2 bottles of alcohol that we can sell are 5. Because after we sell 5 bottles of alcohol too, we run out of resources because 5 times 2 is 10 and we only have 10 units of this resource. So that is why we said W2 less than or equal to 5Z. Okay, I hope you understood why we linearized it this way. Thank you for watching. I'll see you next time. Goodbye.